So also good to know that your $3 million renminbi project has gone through. Congratulations. Certainly, writing proposal is the most memorable or painful process in research. So I think all of you should agree with me, right? But it's the essential one for us to continue with the business. So congratulations for winning the sizable grant in China as a starter, right? And secondly, of course, you are a birth of the second child. So Li Fang must be very busy to be the new mother again, right? So I guess please take care and please send my regard to her as well.
Yeah, Li Feng is here. If she wants to say a few words.
Okay, sure.
Hi, Prof. Wang. Yes, I'm here.
Good. Yeah.
Congratulations.
Yeah, thanks very much for both joining the session. Right? Okay, thanks very much. Thanks.
Thank you, Prof. Wang.
Yes. Now, so we have our next speaker. Dr. Puya Davudi. Puya, sorry, for London now is probably 4 a.m. already, right? Sorry.
It's 5:10. No worries.
Yeah. I should have moved you earlier together with other UK colleagues. So I have already considered the timetable. But
no worry. No worry. That's fine.
Yeah,
that's fine.
Just accept you. Sorry. So you couldn't sleep today. Tomorrow in the class, you could be sleepy. So your student could be complaining to me. So please tell him that the mistake is on me, right?
No worry. No worry. Thank you so much. Yeah, that's great. Thank you very much. Yeah.
Sure. So
okay.
So the title of your presentation is a summary of your previous and current research work. Currently, you are an assistant professor at Keele University in United Kingdom, right? Okay. Puya, please.
Right. Yes. Thank you very much, Prof. Wang. Good morning, good afternoon, and good evening, everyone. My name is Puya Davudi, and I am currently lecturer at the School of Pharmacy and Bioengineering at Keele University. But sooner or later, our school name will change. So if you sometimes you search for the school name later, maybe this month or later, 1 month later, so you don't see this name anymore because they are merging the schools into other schools. Anyway, so let me go ahead with my So this is actually my journey. I left Iran, my home country, in 2011 and joined NUS and Prof. Wang's group in July 2011. And after 7 years of work as a PhD student and also postdoc in Prof. Wang groups.
Okay.
So I moved to the UK, first to the University of Cambridge for 2 years of postdoctoral fellow with Professor Sherry Huang, and finally, so far I end up to Keele University. That is, I'm doing tissue engineering and drug delivery research there, and also I'm teaching pharmacy and pharmaceutical science to the students, to the M-Pharma students. So over the past few years, my research revolved around the biomaterial synthesis, functionalization, and biofabrication for drug delivery and tissue engineering. And in the next few slides, I just show briefly what I've done. So it's just a summary. It's not something like the result. So the first part of the work that I've done in Prof. Wang's lab was designing and synthesis of dual agent drug delivery systems. This includes nanoparticles and also microparticles. For the nanoparticles, I work on the stimuli responsive nanoparticles, and for the microparticles, I work on the core shell microparticles fabricating through electrohydrodynamic atomizations. So this part of the project was the part that I was very interested because we could manage the release profile of different kind of therapeutic agents through the physical and engineering work, not just the chemistry work. And also I start using injectable hydrogels that later I will show you. It's part of my current work as well. So after that, during my first postdoc with Prof. Wang, I started working on 3D bioprinting of the human skin tissues. Is actually the work that I've we've done with a few of the colleagues and friends that they already presented their work today. And after that, I moved to Cambridge, and during the postdoc in Cambridge, I work on the near-field electrospinning process. That in this process, we just reduce the distance between the needle and also the substrate. So in this case, we reduce the voltage, and we could precisely deposit the fibers at the position that we want, and we can. And the group continuously develop this process, and they also they develop some biosensors and so on. So they also use it for the fabrication of something like 3D tissue construct for tissue engineering. So after that, after moving to the Kiel University, I started working on injectable hydrogel for cartilage repair, because this is one of the main sometimes challenges that we have in the UK, especially in the area around the university, in the cities around the university. And we found that actually 1 out of 10 adults in the UK usually suffer from the OA symptoms, and it costs a lot of something like money for our healthcare system to manage these number of patients. So because of that, I focus on these specific tissues, and to see whether we can at least find some solution for the problem. This tissue actually, the cartilage tissue looks very, very simple tissue. Is something that has one kind of cells, somehow a very simple kind of biomaterials, mainly collagen type 2 or hyaluronic acids. But it's very, very challenging, if I want to say, because it has something like we have different zonal compositions in this tissue, and also we don't have any blood vessels, any nerves. So regeneration of this something like this tissue is very difficult and very challenging process. And finally, at the moment, the gold treatment for this kind of patient is just a total knee replacement. So because of that, we have started to working with the surgeons to develop an injectable hydrogels for this problem. And so far, we developed an injectable hydrogels that can something like work as a 2-layer of the hydrogels, for one undercoat, one on top. And we tested on ex vivo. At the same time, we are developing and also using my background on particle preparation. In this case, we used hydrogel particles for something like granular hydrogels for tissue engineering. And this work is ongoing through with my first PhD student that's going to submit his thesis soon, by end of this year. And so far, he won all the 3 or 4 awards from the UK societies, and we will publish these works soon by end of this year. So I finally want to thank all the people that so far helped me. Especially, I want to thank Prof. Wang for lifetime support. I think all the fantastic presentation that we had today can perfectly demonstrate your positive impact on our lives. And I want to especially thank you for all your support during my PhD and postdoc. And I can say that without your help, without your support, I couldn't be the one, and I couldn't be in the place that I am here at the moment. So thank you very much, and I congratulate you for these 30 years of excellence in teaching and education. Thank you, Prof.
Okay, great. Thanks very much, Puya.
No problem.
Indeed, in Linden, I have also received information regarding your student receiving an award, right? So that's a very good publicity work. So I guess that's certainly set a good publicity for you to continue to get people funding the project and to have interaction, right? Thanks very much for sitting up today for
No
the
problem.
presentation. Thanks very much. Okay,
Yes.
sure. Thanks. So we have now welcome our last speaker for today, right? Basically, Associate Professor Fanghua Li from Harbin Institute of Technology. So so the topic of her presentation today is just 1 second. High value utilization of biomass and green circular economy. Fanghua, please. Fanghua, can you hear me? Yes, okay.
Can you see my slides?
Can see slide.
Hello, everyone. First, congratulations to Professor Wang's 30-year journey of research and education. I was a research fellow under the supervision of Professor Wang during 2018 to 2021 at National University of Singapore. Now I am an associate professor at School of Environment, Harbin Institute of Technology. So today my report will, I will give a brief introduction from these three parts. My research interests focus on new energy and materials for carbon neutrality and environmental sustainability. My main research area focuses on selective catalytic conversion of biomass and carbon dioxide to new energy and materials.
Fanghua, can you show your slides? Currently, is stopped at the page 1.
Oh, okay. Sorry, I don't know. Okay, let me try again. Can you see?
Yes, can. Now it's in page 4. Yeah.
Okay. Yeah. So the key points from my study mainly focus on the biomass conversion and manufacturing. The second one is resources, environment, and ecological chemical industry. And the third one is bio-based material development and application technology. So, so this figure contains a lot of words. So I just give a brief introduction. So the cutting-edge technology of oil-enriched microalgae catalytic.
You can now move to the. It's not now stay in page 4, but you can put cursor to the subsequent page, so it will show that page only. Yeah, now we are in slide 4. Yes.
Oh, but I already go to slide 5. Sorry.
So hence, so we can see the small thing next to it, right? So I guess you can. Yes, I think we can go to the.
Here, can see.
Still in the slide 4.
5.
Yeah. Okay. Yes. Now 5 is correct. Yes, please.
Okay. The cutting-edge technology of oil-enriched microalgae catalytic pyrolysis, aiming to produce liquid fuels and functional carbon materials, has attracted extensive concern. The main difficulty limiting its widespread application lies in the high proportion of nitrogen and oxygen elements in pyrolysis oil. We found that nickel-based catalysts can regulate the distribution of heteroatoms such as nitrogen and oxygen in pyrolysis products, and reviewed the catalytic mechanism of nickel-based materials to efficiently catalyze the synthesis of hydrocarbons. By Mike Craigie, a new path was proposed for aviation-grade biofuel synthesis, and a new nanoparticle thermal catalytic system was constructed, which can effectively improve the quality of pyrolysis oil and significantly reduce production cost. A multi-element catalytic pyrolysis reactor was developed based on different types of biomass. The hydrocarbon production increased by 89% from the new designed reactor, breaking through the problems of traditional reactors such as low efficiency, non-environmentally friendly, and high cost. I have published 27 SCR articles in well-known journals as first and crest-building author in this area. Besides the total number of impact factors reached 3,000 and 5,000 with citations from Nature Family Journals, Applied Catalyst B, Environmental Science and Technology. Besides, I also developed a catalytic pyrolysis non-thermal plasma system, carried out the synthesis of biofunctional nickel-based catalysts, and studied the denitrification mechanism of catalytic cracking or organic solid waste, and provide new ideas for the development of liquid fuels based on the cold areas. So I just make a summary about the main academic contributions. Mainly, the majority of them were conducted under the supervision of Professor Wang. So the first one is mechanism of selective conversion. We developed a new nanoparticle catalysts using solid bio waste containing calcium, magnesium, and potassium. So the second academic contribution, targeted conversion technology. We designed photobioreactors, nano air purification and catalytic conversion devices based on different biomass. So the third one, we have obtained the jet fuel specification grade biofuel, and the overall product benefit is 6,000 yuan per ton per biomass. Now I show you some of my ongoing research. So direction one, biomass-derived renewable materials and biofuels for sustainable chemical and environmental applications via solar-driven thermal electrical conversion approaches. And the second one is focused on the machine learning for sustainable development and applications of biomass and biomass-derived carbonaceous materials in environmental remediation systems. So I mainly focus on environmental protection technologies such as high-value conversion of biomass, resource recycling, pollutant degradation, and carbon reduction. So my research processing, the first is focus on developing economical, environmentally friendly, and sustainable technology for high-value conversion of biomass and degradation of environmental pollutants via solar-driven thermal electrical conversion. And the second stage focus on the machine learning methods to high throughput screen candidate materials, optimize structures and predict properties, and develop new carbon-based functional materials for biomass conversion and environmental remediation. And the third stage, machine learning catalytic design for high value products through biomass waste conversion and utilization based on pollution reduction and carbon sequestration. I try to provide feasible solutions to environmental problems and sustainable development. So, yeah. So this is the the last of my presentation, and I really feel great honor to be here to celebrate Professor Wang's 30-year journey of research and education. Thank you.
Okay, Fanghua, thanks very much for your presentation. So you mentioned about the recent new publication, right? So they appear to be in those very top-cited journals, right? So I guess so that will be building a very good trajectory as a young researcher, right? So and you even though in the School of the Environment, so you do a lot of energy related, right? So is the school having the name of environment and energy together, or is only environment?
The name of the school is Environment, but I do collaborations with the School of Energy.
Sure. Okay. Yes. Yeah. Because quite a few titles carry the energy. So I guess the coupling of these two probably will broaden your chance, right, of getting funded as well, right?
Yes.
Thanks very much. Yes. So I think thank you for the presentation, and then let me also to take the chance to thank you for all who contribute to the talk today, right? Today, so sorry for dragging the meeting based on the schedule, but I guess it's probably okay that we will be able to see through all the different presentation and to get to know the detail, right? So I guess this is a good network. So I think we hope to establish a good networking through this, right? So So Fanghua, can you unshare the screen first?
Yeah.
Yes, thanks.
Sorry.
Yes.
Okay.
So well, thank you all for coming to this. So we turn out to have 3.5 hours, right? Rather than the original schedule. Thank you all for staying with us, right? Okay, and so we will keep in touch, and let's continue the connection. And let me wish you an exciting career in front of you, in both business, research, teaching, education, and your personal life, right? Okay. So thanks. So we will close the workshop here, and thank you for your participation.
Thank you very much, Prof.
Thank you, Prof.
Thank you, Prof.
Congratulations.
Thank you, Dawon. Bye.
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 Congratulations.
Bye.
Yeah.
Goodbye.
Bye-bye.